So here's the project that I've been working on for a while now. So if we run it, you can see it is a OpenGL project, a 3D scene where I attempt to capture the finite different time domain microstrip simulation. So here's the basic geometry shift that I've generated so far. So you have the carrier here, or ground conductor. You have a substrate, which is the blue thing, and you have the trace where the electromagnetic wave propagates. Oops. Then you have the source coming from here, and this is supposed to be housing, also the metal. So and you can actually make more complex constructions by moving things around and rotating them as you'd like. So for example, you can move this a little bit to here, put the carrier underneath, and generate the same thing. And then to connect the things, you can actually make a wire, a ribbon, as an interconnect. So you can put something like this, and you can also control the height of the ribbon and also the size of it, and of course the physical properties such as permittivity and conductivity. And you can also do wires. So for example, if you didn't want to put a ribbon here, you could have just as well put the wires. Okay, so this is the other plane. We can put this like this, or something better, but I think the ribbon here is actually quite good. So, but we can put wires to the ground here so that cuts off low frequencies, something like this. Oops. You can also add a power detector, which actually captures the waves and have the generate the S parameters based on the pointing vector in here compared to at the source, and you can display them in separate windows, separate tabs. So this is it, and now for the simulation, for the 3D simulation, so I've created a bunch of cells. So if we increase the cell size, you can actually see every cell. And so my idea is to have a component of the electric and magnetic field in each of the cells. And obviously, as the cell sizes decreases, we have more cells, and it's going to be computationally more expensive. So, for example, in here, you can see that, for example, this ribbon contains 1, 2, 3, 4, like 8, I guess 10 times the height of 3, about 30 cells with this cell size, and the properties, the physical properties are going to be taken, and the fields are going to be calculated based on them, and you can increase the overall cell size the simulation space size. You can add height and width, but of course, the less it is, the faster it will run. So I haven't really fully I haven't implemented 3D simulation at all. What I have implemented is a 1D method, and in it you can see it's similar, but a wave is actually in 1D. So if you decrease the simulation dimension and decrease the cell size, and you put the RF source in here, you can actually run the simulation. So what I'm doing here is I'm generating a Gaussian pulse, and it spreads in both directions. You can do helper line. So the blue one is the electric field, and the red one is the magnetic field. As you can see, they're bouncing around the boundaries, and here they are interfering with each other. So for example, the electric field has undergone the constructing interference there, and here it does the destructive one, so it destroys and kind of reverses direction and continues on. So we can speed it up. And we can stop and we can inspect the fields at any moment. And I think a good idea would be to add probes there, so that we can quantify the fields. So if we reset the field and say add another power source right here, and generate the pulses, you will see that the pulses actually there are more of them because each of the sources generates a single pulse. So we have 2 pulses in both directions, so 4 things in total. So, and as the simulation runs, it will be more of a mess here because of the interference. You can already see that it's a little bit hard to tell that there are actually 4 pulses to begin with, and in a while it's going to be more of a mess. So in the meantime, as I've said, there are I can show you more what I've done here. So as I've said, there are carriers, which are basically conductors. You can rotate them, you can set the dimensions and move them around. Then you can have substrates, which are basically insulators or dielectrics with different conductivity and permittivity. You can have traces as well. Oops. So this is a trace. Again, you can make it very long as you like. You can make it very big or wide. You can rotate it. Well, this is not very. This would not be a very good system if I made it that big. So I guess I make it smaller. Put it on a substrate. I guess what a really good thing would be is to make things to each other. I haven't implemented that because I've never encountered it before I started working with SolidWorks, but it would be very useful so that I can